Welcome to Maths and Science by IITian channel. In this lecture, I would like to discuss about the prime factorization and all integer value to find all integer values d's such that when d is equal to 7 to the power of k into m is not divisible by 7, which are the integer numbers are less than or equal to 99,999, a 5-digit number. How to find out all integer d's? Such that the integer is less than or equal to 99,999. It involves very good concepts useful for both Maths Olympiad and little bit of a tricky problem involving good number of concepts and involving logic also, involving some tough mathematics and number theory and logical thinking, useful for both Maths Olympiad at higher level and also JEE mathematics. Here we are speaking when k is equal to odd. This is also there condition. Two conditions are there. One is integer d is, it should satisfy the condition 7 to the power of k into m, where m is not divisible by 7, and that integer should be less than or equal to 99,999, and at the same time the power k, the value prime power of prime, 7 is a prime number. K is power of prime number such that k is equal to odd. We cannot take all the values of k. I think you understood the concept. It's a little bit tricky and tough, involving a lot of concepts. Definitely, let's go for solving it. It is solvable and a very good example for clearing our many concepts in number theory, especially prime numbers and power of prime number and prime number factorization. A number integer factorization with different prime numbers. Now, let us delve into the question. Please try to understand the question first. Then only we will get an answer. If you don't understand the question properly, like if you are asked a range, you should give the range. When you are asked a number, you should give the number. Similarly here, we are asked to find out number of integers less than or equal to 99,999 such that the integer d is equal to 7 to the power of k into m, where m is non-divisible by 7, and the power of prime number k is equal to odd. These are the conditions given. Now, in this particular set, we have to count the number of elements in the set. The number of elements in a set is cardinality. We have to find the number of elements in the set such that this particular condition is fulfilled. Now, solution, we will go for the solution if you have understood the question. If k is equal to odd, that means k is equal to 1, 3, 5, 7. We should not take the even powers because it is given k is equal to odd. The numbers will be 7 to the power of k means 7 to the power of k into m is equal to 7 to the power of n into m, 7 to the power of 3 into m, 7 to the power of 5 into m, 7 to the power of 7 into m, all these. Now, we have to find out the integers such that it should not exceed, that means less than or equal to 99,999. Now you tell me, a number is given to you. How many integers greater than 0 positive integers will be there? N 99,999 positive integers greater than 0 will be 99,999. That will be 1, 2, 3, 4. These are all integers. Numbers are there. There are 99,999 integers are there. Out of which, how many integers are satisfying this condition? This given condition. There can be number of integers which are divisible by 7 to the power of 1. That means we have to count all the integers. Let us first write. What is 7 to the power of 1? That is equal to 7. 7 to the power of 2 is equal to 49. 7 to the power of 3 is equal to how much? Just see, 49 into 7, 343. 7 to the, let us drop these even numbers because we don't require even. Now, 7 to the power of 5 directly we will go for. 7 to the power of 5 is 16807. What is 7 to the power of 7? It is just a multiplication. Don't worry much about it. 7 to the power of 7 is 823, 543. That means here because k is equal to odd and d is less than or equal to 99,999, it implies as 7 to the power of 7 is greater than 999, We will stop our iterations or counting. We will stop our process of counting when k is equal to 5. Beyond that, not required. Because 7 to the power of 7 is greater than 999, 99,999. We have to find out the integers less than. Hence, 7 to the power of 7 is discarded up to k is equal to 5. Now, if there are some integers number of integers divisible by any number in a big number, how many integers will be there? This is very important. Number of integers divisible by any number n in given number capital N is equal to capital N by N. Please, this is the rule of our number theory. For example, capital N is equal to 100. I want number of members divisible by 7. Small n is equal to 7. Then what will be D? D is equal to 100 by 7. The greatest integer I have to take, that is 15. About the greatest integer, I have already applied in the previous lectures. Please see that previous lecture where we have found out 43 to the power of 430. In that problem, we have introduced the concept of greatest integer. Then here, what is the value of capital N in the given problem? Capital N is equal to 99,999. What is N? N is varying. N is varying because K is varying. N is 7 to the power of 1, 7 to the power of 3, 7 to the power of 5. Because 7 to the power of 7 is not required. Seven to the power of 7 is more than the given, what you call, given conditions, that number. Then what happens? Number of integers in 99,999 divisible by 7 is equal to 99,999 divided by 7, that is equal to greatest integer we have to take. Just see what is its value. These calculations without calculator also you should be able to do. 14285. Number of integers in up to, not in actually, it is up to, we can say up to. Here also we will say up to. We are talking about positive non-zero integers. Is equal to 99,999 divided by 49. 2040. These calculations you do, greatest number. Those are all simple things. Number of integers up to 99,999, it is divisible by, here it is divisible by 49, here divisible by, next number is, what is that? 7 to the power of 5 is 7 to the 343, 7 to the power of 3. 49, actually we have calculated. Why I have calculated this? I will let you know. This is for 7 square. This is 7 to the power of 1. Why I have calculated? I will let you know now. In the just 2 minutes, let me calculate up to 7 to the power of 5. Everything, even and odd also. For 7 to the power of 5, 7 to the power of 3, sorry, it is not 5, 7 to the power of 3, bear with me, divisible by 343 is equal to greatest integer 99,999 by 343, that is equal to, how much it will be? 291. These calculations you please take care. This is for 7 to the power of 1, this is for 7 square, this is for 7 to the power of 4. Now we will go for 7 to the power of 4. 7 to the power of 4. Because up to 7 to the power of 5 we require. Why we require even numbers also, I will tell you. Give me a minute. Number of integers up to 99,999 divisible by, what is 7 to the power of 4? You just see, the value of 7 to the power of 4 is 2401 is equal to 99,997 divided by 2401. Is greatest number we are taking 41. Let us put red color. Now, what is the next 7 to the power of 5? Here, number of integers up to 99,999 divisible by, what is 7 to the power of 5 value? 16807. 16807. That value is 99,999 divided by 16807, 16,807. That value is equal to 5. Now, we have got all the values with us. One is number of integers divided by 7 to the power of 1. I will not write the whole sentence. Is equal to 14285 2. Number of integers divided by 7 square is equal to 2040. Number of integers divided by 7 cube is 291. Number of integers available when the given number is divided by 7 to the power of 4 is equal to 41. 1, 2, 3, it is 4. Everything is number of integers in the given number when divided by 7 to the power of 1, when divided by 7 square, when divided by 7 cube, when divided by 7 to the power of 4. You read like that. Number of integers due to division of the given number by 7 to the power of 5 is equal to 5. These are the numbers we have got. Now, we don't want even numbers. We don't want even numbers. Now you count the odd numbers, please. I have one, because in the question examination they can give even k is equal to even also. In that case, you should be able to answer it. I will just give as a homework, if k is equal to even, what happens? You please find out. This is odd, this is even, this is odd, this is even, and this is odd. When there are 14,285 in the first case, please try to understand. In the first case, when 99,999 is divided by 7, we have got 14,285. That is the total number of integers. This is total number of integers. Please try to understand this logic. 14,285 integers are available, total available, when divided by 7. When divided by 7, anything above 7, 7 to the power of 2, 7 to the power of 3, 7 to the power of 4, 7 to the power of 5, everything is counted. This is the total number. Please try to understand. All integers are counted. All integers divisible by 7 are counted. From this, I have to remove even integers. It should be minus, it should be removed from 14,285. And even integers, this is also counted, that also to be removed. When you remove 14,285 minus 2040, because everything is counted there when divided by 7. 7 to the power of 2, 7 to the power of 3, 7 to the power of 4, everything is counted. And 7 to the power of 2 should be removed, that number of integers. And 7 to the power of 4 also to be removed. Hence, from 14,285 we have to remove all even integer numbers. Add odd integer numbers. Therefore, final answer is when you remove 7 square, what happens? When you remove 7 square, what happens? All 7 to the power of 2, 7 to the power of 4, 7 to the power of 6, 7 to the power of 8, everything is removed. That means 7 to the power of 4 is already removed in 7 to the power of 2. When you take out 7 to the power of 4, 7 to the power of 4, 7 to the power of 8, 7 to the power of 4, that means this whatever 7 square, when it is divided by 7, all are there. When it is divided by 7 square, that whatever 49 7 square, when k is equal to even, that number of integers to be removed, 2040 integers. When it is divided by 7 to the power of 4, that is also even, that is 41 integers to be removed. When number of integers when divided by 7 to the power of 3 and 7 to the power of 5 are there, we will add them. Then the total count, final answer is equal to 14,285. This number of integers are there that are divisible by 7. From that we will take out number of integers, they are divisible by 7 square. Then we will add, because 7 square we have taken out, then we have to add 7 cube integers, that is 2, 4, 7 cube integers are 291, sorry, and take out again 7 to the power of 4, that is it is not 291, sorry, we are making 2040, it should be plus 291 minus 41 plus 5, that is equal to 12,500 integers are there satisfying the given condition. This is the answer. There are total, when divided by 7, containing 7, there are total this much. Out of that, this is even, this is odd, this is even, this is odd, this is even, and this is odd. Beyond that we need not calculate, because the number of integers will be 0. The higher than the given number 99,999. That means when you count the integers, sum of the integers, when we make sum of the integers, counting is nothing but sum of the integers. That means sum of the integers, sum of the counting of integers Here I am not talking about integers getting deleted. Sum of the counting of integers. That means due to as k is equal to odd is equal to 12,500. This is due to 7 to the power of 1. This is due to these two 7 to the power of 3. This is due to 7 to the power of 5. That means the number of integers available when particular number is divided by 7 to the power of 5 or 5 are there. When divided by 7 cube, 291 are there. But after odd number there is an even number, hence we have deducted the even number 7 to the power of 4. This is 7 to the power of 4. This is even number which is deducted is 7 square. 7 to the power of 1. 7 to the power of 1 is full. From that 7 to the power of 2 is deducted. Again 7 to the power of 3 is added, and 7 to the power of 4 is deducted, and 7 to the power of 5 is added. That means the final answer is 12,500. This whatever we have done, this is the procedure for avoiding double counting. Procedure for avoiding double counting. This procedure is adopted. And when I take up this procedure of avoiding double counting, rather we can even call it as inclusion exclusion principle, that I will take up. Maybe after few classes I will take up the inclusion exclusion principle. Let us see how it works. Please have a understanding of, please study inclusion exclusion principle as homework. This principle is to avoid double counting. Please be sure, we have to avoid double counting. For that only we have adopted this procedure and we got the answer. With this, I want to conclude this lecture, and I have given enough of this counting the integers and counting the numbers, counting the integers divisible by something, even for powers to the power of 43 to the power of 430 also we have done in the last class. Like this type of problems, whenever they come, please do them in this procedure which I have explained in the previous class, previous lecture, when I have dealt with this and this lecture, and be guided. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture, And if you feel there is a value addition because of this lecture to you, kindly share my channel and video details and kindly subscribe to my channel. My channel name is Maths and Science by IITian. You try to understand and grasp the principle, grasp the type of questions I try to solve here, so that if you practice this type of problems, you start gaining confidence and you start learning something new. Learning something new is always better in life, and learning new concepts. Keep that in mind, new concepts. If there is a little deviation, please look into the standard textbooks and try to understand the main principles. I try my level best to explain everything to you, but still, and learn new things. My lectures are meant for learning new things instead of only solving the regular problems. And especially higher mathematics question papers, examinations involve something new, something challenging. In my lectures, I have given most of the questions on the base in a challenging way, without repetition. I tried my level best. Thank you for listening to me. Thank you for viewing. Best of luck to everybody. Please share my videos and please subscribe to my channel. Thank you.